Welcome to this session of assignment model. If you are coming across my lecture for the first time, please don't forget to like the video, also share it with others, subscribe so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you. Now, this is the part 2 of my presentation on assignment model. In this part 2, I want to examine the maximization objectives or maximization objective. In part 1, I've examined minimization objective. Now, maximization objective. Maximization objective. Steps for solving assignment problem or problems involving maximization. Step 1. Ensure that the assignment problem is balanced. I've told you that a balanced assignment problem is the one that forms a square matrix. I've told you that a square matrix is the type of matrix in which the number of rows equal to the number of columns. Rows equal to column. That is step 1. So if it is a balanced problem, then you can proceed directly to solution. But if it is not balanced, I've told you that you will need to introduce a dummy activity, which may either be introduced to row or to column. Go back to part 1 for better understanding. Step number 2. Subtract the highest element from each row and also do the same for each column. Subtract the highest element in each row from every other elements in that row. Note for minimization, it was the lowest that were used, but this is maximization. That is why you use the highest element. Also do the same thing for the column. Also do the same for column. Also do the same for columns. Step 3. Cover all zeros with the minimum lines possible. Cover all zeros with the minimum lines possible. If you want to cover zeros with minimum lines, so you start from where you have more number of zeros. You cross it or you cover it either vertically or horizontally where you have more zeros. That is where you are going to start from. You cover all zeros with the minimum lines possible. And where the number of lines you have equal to the number of assignments. Where the number of lines equal to the number of assignments, then that means the optimal solution has been achieved. If the number of lines and assignment, if they are equal, then that means you have gotten the solution. But where the number of lines is not equal to the number of assignments, that means there is no solution yet. Then you proceed to this step. Step 4. If there is no solution, if there is no solution, that is, if the number of lines is not equal to number of assignments, that is what I mean by if there is no solution. Select the highest uncovered element. Select the highest uncovered element, not the lowest this time around. It is the highest uncovered element that will be used. Select the highest uncovered element and subtract this number from all elements that have no line through them, and subtract this number from all elements that have no line through them. It is elements that have no line through them that we are going to subtract the highest uncovered element from. Then you also add it to the number at the point of the intersection of two lines. Also, add this number. What does that mean by this number? The highest uncovered element. That's what I mean by this number. Add this number to the number at the point of intersection of two lines. Point of intersection is the point where two lines meet. If you have one horizontally and one vertically, this is the point of their intersection. And if you also have another one, this is the point of intersection of these two lines. Where two lines meet is their point of intersection. So, if there is no solution, it is then that you proceed to this step. You again cover the zeros with the minimum lines possible. And where the number of lines equal to number of assignments, that means the optimal solution has been achieved. But if otherwise, then you also repeat this step until the optimal solution has been achieved. These are the steps. Example: 4 different airplanes are to be assigned to handle 3 cargo consignments with a view to maximizing profits. The profit matrix is as follows in 100 rupees. We have cargo assignments and we have airplanes. Airplanes W, X, Y, Z. Y cargo assignment A, B, and C. W 145 233 333 512. You are to work out the optimal assignment plan for the above. Remember, the objective in this case is to maximize profits. We used to maximize profit. You are given profit matrix. You are given profit matrix and you want to maximize profit. Now, since you want to maximize profit, then the first thing, you are going to follow the steps I have given to you. You are going to check if this problem is a balanced assignment problem. So now, let's check the row. We have row 1, row 2, row 3, row 4. 4 rows. Column 1, column 2, column 3. 3 columns. Since the number of rows is not equal to the number of columns, then you are going to introduce dummy. That means we need to introduce dummy here. If you introduce dummy here with 0 cost, we will now be having 1, 2, 3, 4 columns. So now let's introduce dummy. So introduce dummy activity. Dummy. I've told you that the essence of that is to make the assignment problem to be balanced. We have cargo assignment. Cargo assignments. And we have airplane. Cargo assignment A, B, C. A, B, and C. Airplane W, X, Y, Z. So you are given 1, 2, 3, 5. 1, 2, 3, 5. 1, 2, 3, 5. Then you have 4, 3, 3, 1. 4, 3, 3, 1. You have 5, 3, 3, 2. 5, 3, 3, 2. 5, 3, 3, 2. Then I said you are going to introduce dummy here to make it balanced with 0 profit, since the objective is to maximize. Now, it is a balanced assignment problem because you are having 4 rows. Row 1, row 2, row 3, row 4. And 4 columns. Column 1, column 2, column 3, column 4. It is a square matrix now. 4 by 4 square matrix. This is 4 by 4. 4 by 4 square matrix. It is now a square matrix. That means the problem is a balanced problem. Now, you now want to reduce each column by the highest element in that column. The highest in this column is 5. Let's have A, B, C, dummy. Then W, X, Y, Z. The highest is 5. 1 minus 5, that will be 4. 1 minus 5, that will be minus 4. Minus 4. 2 minus 5 will be minus 3. 3 minus 5 will be minus 2. 5 minus 5, then you have a 0. The highest in this column is 4. 4 minus 4 is 0. 3 minus 4, that will be minus 1. 3 minus 4, minus 1. 1 minus 4, minus 3. Then this column, the highest is 5. 5 minus 5 is 0. 3 minus 5, that will be minus 2. 3 minus 5, minus 2. 2 minus 5, that is minus 3. You already have zeros in the dummy column. Now, let's cover all the zeros with the minimum lines possible. You have 4 zeros in dummy column. Let me cover that first. Then you have 2 zeros here. Let me cover it. That is 2 lines. Then you also have 1 0 here. If you like, you can cross this like this, or you cross it vertically. Anyone, let me cross it vertically. Now, you have 1, 2, 3 lines. And how many assignments do you have to make? 4 assignments. The number of lines is not equal to number of assignments. That means the optimal solution has not yet been achieved. The next step, you identify the highest uncover element. The highest, these are the uncover element. The highest is minus 1. I want you to know that minus 1 is greater than minus 2. Minus 1 is greater than minus 3. Minus 1 is greater than minus 1,000. And minus 1 is greater than minus 1 million. So take note of that. Don't think because minus 1 is a small number. 1 is greater than 2 is greater than 1, but if it is negative, the smallest number in terms of negative integer is always the highest. So 1 is the highest uncover element. You reduce the uncover element by the highest number, which is minus 1. And at the point of intersection, you add it there. Now, let's have let me say table 3. Table 3, A, B, C, and dummy. Then we have airplane. W, X, Y, Z. Now, we said minus 1 is the highest. This is the point of intersection of 2 lines. You are going to add it. You know you have minus 4 already. Minus 4 plus minus 1. Minus 4 plus, you know the highest number is minus 1 we have chosen. Minus 4, you are adding it to the point of intersection. That is why we have plus. Minus 4 plus, and it is minus 1. You want to add to it. Because we are adding it. That is why I have plus here. So which is minus 4 Plus times minus is minus 1. Minus 4 minus 1 will be minus 5. So that means this change to minus 5. So we have minus 5. This one we have is 0, 0, 0, 0. This is dummy, and this is also a point of intersection of two lines. So we are going to add that minus 1 to 0 here. So we have is 0 plus minus 1, which will be is 0 plus times minus will be minus 1. Is 0 minus 1 will be minus 1. So that means the number here becomes minus 1. So we have minus 1. Take note of that. This minus 3 is a single line, so we write it minus 3. This is minus 1. Minus 1. Minus 1. Minus 1, no, you are subtracting minus, and you have minus 1. You want to subtract from it. So we have minus 1. Minus times minus become plus 1. Minus 1 plus 1 will be 0. So that means this one now, if you subtract minus 1 from it, you have a 0. So that means we have a 0. This one too will be 0. You have a 0. Okay, let me deal with the row first. Minus 3. This becomes 0. Minus 2 minus 1. It will be minus 2 plus 1. Minus 2 plus 1 will be minus 1. So this one becomes minus 1. Then this will still remain 0. Then minus 2. A line runs through it. So that is why it will not be affected. Minus 2. Minus 1 minus minus 1. It will be minus 1 plus 1, which is 0. Minus 2 minus 1. It will be minus 2 plus 1. Minus 2 plus 1 becomes minus 1. So just like what I've done in all these cases, take note when it is subtraction. So that's why we have minus, so that you will not be confused about how we got minus. Take note, because of subtraction, and the numbers we are subtracting carry is a negative number. Take note of that. And the minus and minus become plus. Then we have 0. Then this one will still be 0 as well. Minus 3 minus 1. That is minus 3 minus 1. That is what I mean. It will be minus 3 minus plus minus become plus. Minus 3 plus 1, which is minus 2. So this will be minus 2. So minus 3 minus 1 also will be minus 2. Then, since it is a single line that crosses it. So, now, I said we have 4 lines and 4 assignments. 4 lines and 4 assignments, so we can make our assignment airplanes to cargo assignments. Now, cargo assignments. Then we have airplanes. So we have W, X, Y, Z. Will be assigned to W. Now back to the table. Now we have 2 zeros here. Let's check the one with the least zeros first. We have 2 here, we have 2 here, and we have 2 here. So, but if you look at the possible assignment, this is the only 0 we have in this column. That means this number can only be assigned to this. If you assign, if it's not assigned this to this, it can either be assigned to this. But since there is no place any other number can be assigned here, apart from Z that can be assigned to this, so we consider assigning Z to this first. Z to A. Z will be assigned to A. I've told you if you did not assign Z to A, there is no number can be assigned to this column. No place any number can be assigned to in this column. So apart from Z that can be assigned to this. Now, let's consider assigning other number. If you assign Y to this, okay, look at this 2. This one 2. W can be assigned to this place or this place, but no number can be assigned to any other place apart from this place that you can assign number to, since no zeros is in this column apart from this. That means you can only assign W to this, which is C. W will be assigned to C. Since W have been assigned to C and Z to A, we are left with X and Y. So you may consider assigning X to B. If you assign X to B, then dummy will be idle. Or dummy, I've told you that this will be idle. Then if you assign X to B, you can assign Y to B again. Then you assign Y to dummy. Then if you assign Y to dummy, then B will be idle. So we said W have been assigned to C, Y, Z have been assigned to A. These are the possible assignments: W to C, X to B, Y to dummy, Z to A. Or W to C, X to dummy, Y to B, and Z to A. These are the possible assignments. What will now be the maximum profit? Let me call this one first, this one second. So first, second. So for first now, W to C. W to C, 5. 5. Second will also be 5. X to B. X to B, 3. X to B, 3. Or X to dummy, profit for dummy is 0. Y to dummy, dummy is 0. Or Y to B, you know profit for B is 3. Z to A. Z to A, which is 5. So what is the maximum profit? 5 plus 3, that is 8. 8 plus 5, that is 13. Remember, you were 200, so it will be 1,300 rupees. For the second option, 5 plus 0 is 5, plus 3, 8, plus 5, 13, which is 1,300 rupees, since the amount is in 100. This is the end of the solution to the question. These are the possible assignments.